Okay, guys, so I don't really remember where I was. Okay, here. So, awesome. Electrons orbit around the outside edge. So here, y'all are gonna pull, drag and drop, and like I said, when you open these in a Google Slides, then you're able to actually manipulate and type in it. So I will do that for y'all, so you can see what I mean. Y'all can hear my lo-fi beats. They're so nice. Okay. Presenta. So here we go. So when you are working on this on your own, you're able to type into it. You're able to move all these little boxes and these pieces. So right here, you'd click on this, and then you would literally click on this until it kind of gets that outline right there, and then you would physically move. So which one is neutral and has no charge? The neutrons. And then that's all you do, y'all, is you just move those. So 1/2000th. Trying to get my little crosshair. Where are you at, yo? Right there. So 1/2000th would be electrons. Negatively charged would be electrons. Positively charged would be protons, because the protons are positive. And then found outside the nucleus in the electron cloud would be electrons. And then protons and neutrons are found inside the nucleus. And then a massive one would be protons and neutrons, because electrons barely have any mass at all. So there we go, y'all. So that's all I wanted for that one. Okay, next one. I just want to know what are some things you can use to make atoms of models of atoms at home. So you can use like M&Ms, different color M&Ms for protons and neutrons, and then use something smaller, like maybe sprinkles or maybe little chocolate chips for the electrons. You could do Skittles, you could do pom-poms, different colors. You could do pennies, heads up for protons, tails for neutrons, and then use dimes for electrons. The big thing, y'all, is that protons and neutrons should be the same size and electrons should be smaller. Oh, guys, I didn't know I could do that. That's cool. Okay, sweet. So periodic table shows all the elements. My man Dmitry Mendeleev organized this. Different colors for different things. So I remember L, M, N. M comes first. So I remember the metals are on the left and the N non-metals are on the right, because you read from left to right. So M comes first, so metals and then non-metals. Here's just kind of a review. The atomic number tells you protons and electrons. Symbol, name, and then this, if it's rounded, it's a mass number, and if it's not rounded, then it is an atomic mass. So ape man, APE, so you have A, which is atomic number, equals the number of protons and the number of electrons. And then you have man, mass number. So mass number equals the atomic mass rounded. And then the mass number minus the atomic number equals the number of neutrons. So ape man. So that's a nice little acronym to help you remember how to find protons, neutrons, electrons. So type your answer here. So number one is 1 proton, so that would be hydrogen. The second one has 7 protons, so that'd be nitrogen. This one has 8 protons, so it'd be oxygen. And this one has 5 protons, so it'd be boron. And I figured that out by looking at the atomic number. I'm going to skip that one because right here it tells you. So I'm going to calculate the number of protons, calculate the mass, and calculate the number of neutrons. So if carbon has a mass of 6 and then neutron 6, you subtract these two. So it would have 6. Bye, y'all. It would have 6 protons. Beryllium, to find the mass, you do 4 plus 5 to get 9 as the atomic mass. And then this is like a mystery element. So which element has atomic number 5? It's boron. So if it has 5 protons, its atomic number is 5. And then magnesium, to figure out the neutrons, you do the atomic mass, man, M-A-N, mass minus atomic number, which is also protons. So that would be 12 neutrons. And then here you're just going to describe what you learned about the structure of an atom. What does it look like? What are the parts? What are those charges? Where are they located? What's the mass? All that jazz. And then don't forget, you can look on the Atom Study Guide and you can hit the next button and that will pull up this, which is the answer key that I just went over. So you have it there for you as well, just in case I went too fast right here. And then here is the ion slideshow I already went over. So that was for Wednesday, October 21st. So now I'm going to do today, Thursday, October 22nd. So y'all, I already went over the answer key for that. Same thing, open it up, open in Google Slides, and then plug in those answers for ions and isotopes. Make sure you pass both of them in. You'll notice that I had some students' names for students that have passed the things in. So you're going to go right here, same thing. You're going to click open this, and you're going to click open this, and then you're going to hit open in Google Slides. That way you're able to type into it, and then you're able to go back into your Google Drive, and you're able to access it, and you're able to fix it and change it, which is pretty cool. And then not only that, y'all, you can have it as a resource to study for your quiz. Test, not quiz, test. Okay, y'all. So I'm going to post a key for this one at 5 p.m. So please do not look at it unless you've done it. It's not going to help you at all to write down answers from an answer key, for real. I'm just looking at this quick. I'm giving you credit if you have it. And that's pretty much it. Let me hit pause on this real quick, y'all. Am I even recording? I think I am. But this other one's here. Hold on, I'll be right back. I want to go. Change my. There's an atom, I think. Hold on. Okay, sorry, it was distracting me. Okay, so periodic table and reactivity, and then I'm going to open it right here, and then I'm going to open it in Google Slides so that way I can edit it and see it. Okay, I'm going to hit present, y'all, so I can go through this. And honest to goodness, I hope I'm recording because I can't find anything. So I guess we'll find out when I finish this if I have to redo this or not. Okay, so same as the beginning last time. If you were quizzed, which one of these would you know? Which one would you need help with? Okay, so we already went over all this stuff, so I'm not going to kind of scoot through it again. It's just to help you remember. So valence electrons are in the outermost shell, so you're going to answer that question. Periodic table arranges all the elements in order of increasing atomic number. So you notice 1, 2, 3, and it goes all the way up to 118 on this version. Since the atomic number increases, so doesn't the atomic mass, because more atomic number means more protons, neutrons, electrons, which means more marbles in the bag, which means it's heavier. So y'all should drag and drop these. I'm not going to give these answers away yet because I want you guys to do them. So you're going to drag and drop these where they go. And then you're going to use that to answer these questions. Y'all, pay particular attention to these slides, 9, 10, 11, because this gives you new information. This gives you new information that you need for these ones. So, metals, my trick is, like I said, L, M, N. M comes first. So I remember this side is the metals, and this side is the non-metals. Plus, y'all, common sense it up. Chromium, iron, cobalt, nickel, copper. Those are metals. Nitrogen, oxygen, fluorine, helium. Those are not metals. So you can kind of tell that as well. Metals are solid. They're shiny. They're able to be bent, moved. They're great conductors, and they're high in density and melting point. And reactivity, those metals at the bottom left corner are the most reactive. So, for example, these ones, because remember, if you only have one valence electron, you only have to lose one. If you're full, you've 8, ATE or EIGHT. Yep. So it's easier to lose one valence electron, and it's easy if you have 7 to gain 1. So columns 1 and column 17 are super reactive. Column 18, y'all, remember, kings and queens, noble gases, they already have 8. They're full. They don't want to interact with these peasant elements. They're good. They're like, I don't need you. They're absolutely non-reactive. Like, they do not react with other things. And then as you scroll to the right of the period, it gets less reactive. And then you get here, you have 3 electrons, valence, 4 valence, 5 valence, which means, y'all, you need 5 more, 4 more, 3 more, 2 more, which is harder to do than to just gain 1 or just lose 1. So then you have your nonmetals, the reds. They are poor conductors. They don't conduct electricity. They don't conduct electricity well. They're brittle. They break easy. They're not bendable, not malleable, and they have low density, low melting point. Then the metalloids, y'all, my favorites. They're like kind of a little bit of both. They're like a hybrid. So they're kind of a metal, kind of a nonmetal. And it's along this zigzag. We call it the staircase. Some periodic tables show aluminum. Some periodic tables show astatine. So it just depends. We're going to stick with what it says here. So those are metalloids, and they have some quantities or qualities of both. So you're going to go through these A, B, C, D, E, F, G, and you're going to type what you know about them, and you're going to classify them what you think as a metal, non-metal, or metalloid. Period. Write a sentence, put a period at the end. Periods go across, and that tells you the number of shells. So row 1, period 1 has 1 shell. Row 2 has 2 shells, and it makes sense, y'all. If you have 3 electrons, how many fit in the first shell? 2, which leaves you with 1 to go in the second shell. And then beryllium, 4, 2 in the first, 2 in the second. Boron, 5, 2 in the first, 3 in the second. And it keeps going until you get all the way to neon, 10, 2 in the first leaves 8 in the second, which is the perfect amount, which is full, which is why neon's a noble gas. And then 11, sodium. You start with 11, which means you have 2 in the first, so now you have 9. Can you put 9 in the second shell? No, because it only holds 8. So you put 8 in the second shell, and then you still have 1 left in your third shell. And y'all, check it out. Sodium is in the third row, or the third period. So all of these have 3 shells, 4 shells, 5 shells, 6 shells, 7 shells. Those in the same period have the same number of energy levels or shells, and they grow by 1. Versus columns or groups or families have the same number of valence. So column 1 has 1 valence. Column 2 has 2 valence. These don't count for the rule. 13 has 3. 14 has 4. 15 has 5 valence. Then 6 valence. 17 has 7 valence. And 18 noble gases has 8 valence. Elements in the same column or group or family have very similar properties, y'all, because they have the same number of valence electrons, so they react similarly with other elements. And then as you go down in the column, the atoms get bigger, but the number of valence electrons stay the same. So inert, y'all, over here is just another word for stable, which means not reactive. So group 18 is very stable because they got their lives together. Okay, so you're going to use a dark drawing tool, and I want you to circle, read the directions, circle group 1 in green, period 1 in red, and do what it says. I don't want to go over them, y'all, because I want you to do it yourself. And then read these ones. Moving down the period, rows 1 to 7, number the energy levels or shells, and then do the next one as well. So trends, columns 1 through 18 have the same number of valence electrons in each group. Like we said, group 15 all has 5 valence electrons. Yes. And then this is periodic table and reactivity also, like I was talking about. The ability of atoms to combine or separate other atoms creates a chemical reaction. Valence electrons are the key to do this. If you're full, you've 8. You always want 8. If you have 7, how many more do you need? 1. If you have 1, you're going to get rid of that 1 so that you have a full shell underneath. What happens if you have 6? Then you need 2. So 1 from group 16 that has 6 is going to hook up, react, connect with 1 from group 2 because 6 plus 2 equals 8. So that's why you often see H2O, because O, oxygen has 16 and hydrogen has 1. So if you have 2 hydrogens hook up with an oxygen that has 6, then 6 plus 2 is 8. So it's happy, it's ready to go. And reactivity changes across the periodic table. Like I said, highly reactive, less reactive, not reactive, highly reactive, not reactive. So look at the elements for period 2 and then answer the question based off of what I just talked about. So what makes an atom happy or stable? Y'all, we talked about this. If you're full, you've 8, a full shell. Helium's the only exception that's happy at 2 because remember the first shell is full at 2. All these other dudes and ladies are full at 8. So periodic table and reactivity. What happens if an atom doesn't have 8, y'all? Well, guess what? It wants to get 8. It wants to be full. It wants to eat. So if it has 2, then it either is going to lose the 2 or it's going to try to find 6 more. Okay, and then you can look at the next slide. So hydrogen and hydrogen, 1 and 1, together make 2, which means that first shell is full, so they're very happy. And y'all, this is like a little like mystery business. Let me see. And it says slide this box over after you've answered the question on the previous slide. So scroll it down, and then it gives you the answer. So hydrogen bonds easily with itself. Okay, go to the next one. So let's look at oxygen. If oxygen has 6, it's in group 16. To make it 8, it's going to have to find 2 more. So it needs to bond with one atom that has 2 valence or 2 separate atoms that has 1. So what do you think it's going to bond with? And it's going to bond, like I just said, H2O, so oxygen, and then it's going to bond with 2 hydrogens, so that way it has a full shell of 8. And then scroll it down, and it tells you some more info. Pretty cool. I like those peekaboo boxes. So periodic table provides essential information on elements. Pick 2 elements and compare their atomic structure. So pick 2 elements. Tell me everything you know about both of them. And then, y'all, this is similarly so, this or that. So what are vertical columns? Vertical is up and down. Are they called groups or are they called periods? I think they're called groups, so I'm going to pull it right there. And the number is 8. So then in here, I'm going to type number 8 as the first number of my secret code. And then horizontal rows, I know, are called periods. So I'm going to sneak that one over and see that it's number 1. So then I'm going to put a number 1. And you keep going down until you get your secret code, and you can check the answer key to see if you have your secret code correct. And then sum it up, check for understanding. Are you able to tell me how valence electrons determine chemical properties and reactivity? And are you able to interpret the arrangement of the periodic table to tell me what it means? What do the periods mean? What do the columns mean? And then last but not least, which essential question do you still need help understanding? So the 2 essential questions are here. Do you need help understanding one more? So y'all, that's it. Peace out. You fill my buckets each and every day. I love each and every one of you, and be ready for the test tomorrow, Friday, October 23rd. Bye, y'all.
Hello, welcome to Atom Thingy Part 2 because I could not think of a better name. Today we will be learning how to identify an atom based on its atomic structure, how to calculate the mass of an atom using protons and neutrons. We will be learning what are valence electrons. We will be learning how to determine the number of protons, neutrons, and electrons in an atom. And we will discuss the similarities and differences between ions and isotopes. The first one is fairly simple. The identity is based on the number of protons it has. For example, hydrogen has 1 proton, so it is the first in the periodic table. The second one is also pretty easy. How do you calculate the mass of an atom using protons and neutrons? Protons and neutrons are really the only ones that add weight, because electrons are basically nothing in weight. Protons are equal to 1 AMU, and neutrons are a bit less than that. So what you can do is you can take the atomic mass and subtract the atomic number, or protons, by it, and you will get the neutrons. Make sure you round though. Next, what are valence electrons? Valence electrons are the electrons in the outer shell. The electrons in the outer shell are normally used, or help, to find other elements to collide with. How do we determine the number of protons, neutrons, and electrons in an atom? Protons, well, let me state this first. You can find all of this in the periodic table of elements. For example, protons will be the big number, or the atomic number. Neutrons aren't listed there, but you can find it out by the atomic mass. like shown how to calculate the mass, like shown before this, sorry. Electrons are normally equal to protons, but you can calculate it. For example, hydrogen has 1 proton, normally 1 neutron, and 1 electron. An isotope is a change in the number of neutrons. An ion is a change in the number of electrons. They are both changes, and they both make atoms different. Those are everything we were supposed to discuss. So, yeah, have a great day.